Here are the two special right triangles. One of them is a 45, 45, 90. Why is it special? Because it appears a lot. This is a 30, 60, 90. That's not my best drawing. Now, I'm going to leave it though. Okay, it turns out if you have a 45, 45, 90, the ratio of the sides is always the same thing, or a 30, 60, 90. So, if these two angles are the same, do you know what I know about this triangle?
Those two sides are the same.
Yeah, the two legs have to be the same. Because remember the isosceles triangle tricks? If you have two congruent sides, you have two congruent angles across from those sides. This side and this side are the same. Anyway, so the ratio of those two sides is always going to be 1 to 1. Does that mean that one of them's 1 foot and the other one's 1 foot? And no, it means if one of them is like 5, the other one's going to be 5. If this one's 10, the other one's 10. That means they're the same length. 1 to 1 ratio. Okay, the hypotenuse, the longest side, if I did Pythagorean Theorem, I'd get 1 squared plus 1 squared is 2, so it would be like square root of 2. So the ratio of the sides in a 45, 45, 90 is 1 to 1 to square root of 2. You write it like that. There's a ratio for you. Okay, so a really quick example would be, well, I said 5 earlier. So if one leg is 5, the other leg's going to be 5. Guess what the hypotenuse would be? Well, yeah, to go from 1 to square root of 2, basically this is square root of 2 is square root of 2 times bigger than 1. So you just multiply by square root of 2. 5 times square root of 2 is 5 square root of 2. So this would be a 45, 45, 90. That's an example. It gets a little bit trickier if they start off by giving you the hypotenuse. If the hypotenuse is 10, well, how do you think we go from hypotenuse backwards to a leg? Well, if we multiplied by square root of 2 to get here, then to go backwards, you'd have to divide by square root of 2. So to find the leg in this case, I would do 10 divided by square root of 2. Those don't really mix very well. If you have a nice calculator, you can plug it in and it'll solve it. But the other way to do it by hand, you don't leave the square root of 2 in the denominator, and you get rid of the square root by multiplying it by itself. Because square root of 2 times square root of 2 is normal 2. And then 10 times square root of 2 doesn't simplify. But 10 divided by normal 2, normal 10 divided by normal 2, that does reduce to just a 5. So that would be 5 square root of 2. If that leg is 5 square root of 2, then the other leg is 5 square root of 2. Okay, so the legs are always the same. The hypotenuse is square root of 2 times bigger than the legs. Okay, on a 30, 60, 90 triangle, they always have the same ratio of sides. Also, anytime you know what the angles are, the ratios are going to be the same. But what we do on that one is the small leg, so these are the two legs. There's a small leg across from 30 and a big leg across from 60. I made it a little bit too tall and skinny, but kind of screwed up. But it looks something like this. It turns out, I'll make it look a little bit better. It's bugging me. Yeah, that looks about right. Okay. The small leg to the hypotenuse, the smallest side to the biggest side, the ratio is 1 to 2. What does that mean? It means the hypotenuse on a 30, 60, 90 is always twice as big as the short leg. Okay, on the other hand, the long leg is square root of 3 times bigger than the short leg. So on these kinds of problems, I always work from the short leg. Like, once you know what the short leg is, then you can figure out the other one. So basically, the long leg is square root of 3 times the short leg, and the hypotenuse is 2 times the short leg. Okay, so the ratio is 1 to square root of 3 to 2. Alright, so a quick example would be, let's say this is like 8 or something. I hear food back there. What is it? Okay. Okay, anyway, if the short leg is 8, what do you guys think the hypotenuse is going to be? 16. Just twice as big. But if the short leg is 8, what's the long leg going to be?
8 squared.
Right, you got it. So it's kind of like this one. It's 5 squared root of 2. So this one is 8 squared root of 3. If you have to go backwards from the long leg to the short leg, it's going to get smaller, so you have to divide by square root of 3. But anyways, that's the general idea. They're called special right triangles. They're just really, really cool. So, for example, this 45, 45, 90 is, when you split a square in half, you get a 45, 45, 90. So they just kind of happen to show up, because we use squares a lot for stuff, smartboard or whatever, they just kind of happen to show up a lot. And 30, 60, 90s kind of show up a lot too. So it's kind of a, if you remember these ratios, it's a way to get the missing sides really quickly. All right, we're ready to start. I don't know if that's going to work. Yeah, it's probably just not going to show up very well. All right, anyways, page 321, 1 through 16, here we go. Yep. Number 1, looks like a 45, 45, 90. No, you don't have to draw it. And one of the legs is 18. So if this leg is 18, what's this one going to be? 18, right? So just put B, that's B equals 18. And the hypotenuse, they called it C. So what's the hypotenuse going to be? 18 square root of 2. Yes, that is correct. You got that from right there. 18 square root of 2. This kind of overlaps the Pythagorean Theorem that we did yesterday. If I knew these were both 18, I could do Pythagorean Theorem and get that. But that would take a lot longer than what we just did, right? It took us like 2 seconds to write that down. All right, anyways, number 3. What kind of triangle is number 3? Well, the legs are the same. So these angles have to be the same. So it has to be a 45, 45, 90. Remember the angles also. On a triangle, the angles have to add up to 180. So if this is 90, that leaves 90 for these two. So if they're the same angle, they're 90 divided by 2, 45. Yeah, so number 2, same thing on number 2. Those angles down at the bottom are the same. So they both have to be 45. So 45, 45, 90. Basically, 1, 2, and 3 are 45, 45, 90, and 4, 5, and 6 are 30, 60, 90s. It tells us the hypotenuse is 5. Oops, did I accidentally do this problem? No. I did one with the hypotenuse at 10, so it was a little bit different. So how do I move from the hypotenuse to the leg on a 45, 45, 90?
With that division thing, so you have 5 at the top and the square root of 2 at the bottom.
Okay, 5 divided by square root of 2. So to move up from the leg to the hypotenuse, we multiply by square root of 2. So to move down, we divide by square root of 2. If you have a nice calculator, they can do this by itself. If you have to do it by hand, you want to get rid of the square root on the bottom, so you multiply by square root of 2. So the top becomes 5 square root of 2, and the bottom becomes normal 2. Yep. So it's 5 square root of 2 over 2.
We put 2.5 square root
Let's just leave it like this. This is the more common way of writing it. That was for R, but R and S are the same thing, right? So let's just put R equals S equals 5 square root of 2 over 2. This calculator, those two calculators should be able to do it. This one can. That one, I'm not sure, I'd have to look at it. That one definitely.
Texas Instrument.
Yours can't.
Yeah, that's what I said.
Yeah, this one is Texas Instrument also, but it can do it. That one can do it, that one can do it. I've got some white calculators that can do it. Anyways. Where are we at? Number 5? Okay, 5 is, they switched it to a 30, 60, 90. So that must be 30. Okay, 12 is the what side on the hypotenuse. So what you want to do on the 30, 60, 90s is always go through the short leg. So if the hypotenuse is 12, do you know how long the short leg is going to be? 6. It's 2 to 1. That means the hypotenuse is twice as big as the short leg. So if this is 12, the short leg is 6. So this is the short leg on this one. They called it F. So F is 6. And then if the short leg is 6, what's the long leg going to be? 6 square root of 3. You just tack on, you multiply by square root of 3. So it's just 6 square root of 3. And that was the G. 6 square root of 3. On 6, the long, that's 15 is the long leg, you see that? So that would be this one right here. How do you go from the long leg to the short leg? You have to divide by square root of 3. So that would be one of the cases where a good calculator would come handy. But yeah, that would be your first step. Number 7, kind of the same thing, they just, I don't know, they wrote it differently. AB is 8. On number 7, AB is the hypotenuse on the 45, 45, 90 triangle. Yeah. Okay, so, and we're supposed to find the other two sides. So if AB is 8, how do I find CB, I guess?
4 times square root.
Huh?
Is it 4 times square root?
Yeah, but how did you find that? So if you're going from 45, 45, 90, if you're going from hypotenuse to short leg, you divide by square root of 2. It's getting smaller from here to here, so you're dividing by square root of 2. 8 divided by square root of 2 turns out to be 8 square root of 2 over 2, which is 4 square root of 2. Oops. So if CB is 4 square root of 2, what is AC? 4 square root of 2. Same thing. think you're supposed to put like CB equals 4 square root of 2, AC equals 4 square root of 2. Square root of 2 is worth about 1.4, so if we did like 4 times 1.4, it would be about, 4.87 something. Anyway, it's some decimal close to 5, but
Maybe not 45. Simply don't.
huh?
Never mind.
Number 7 and 8 are using the 45, 45, 90 triangle, and number 9 and 10 are using triangle XYZ, the 30, 60, 90. So on number 9 it says ZX is 24. So that's this one on 30, 60, 90. All right, 24 is the which side? It's the long leg. It's the long leg. So that's like this one over here. So how do we go from the long leg to the short leg? Huh? Divide by square root of 3. Yeah, it's getting smaller. So it's 24 divided by square root of 3, which simplifies to 24 square root of 3 over 3. Square root of 3 times square root of 3 is square root of 9, which is normal 3. Anytime you square a square root, multiply it by itself, it just becomes a normal number. 24 over 3, 24 divided by 3 is 8. So it's 8 square root of 3. That's the short leg, which they called it YZ. YZ equals 8 square root of 3. We're still looking for YX, the hypotenuse. So if this is 8 square root of 3, how do we go from the short leg to the hypotenuse? Times 2, yeah, it doubles it. How do you do 8 square root of 3 times 2? Well, what happens is square root of 3 times 2 doesn't simplify very well, but 8 times 2 does. 8 times 2 is 16, so it's 16 times the square root of 3. 16 square root of 3. That would be 8. Mason. Missed all the fun.
Good thing you were recording. I'm thinking of again though.
You filled your permit then?
Yeah.
Alright, number 11.
It's just a 4 times to get to this.
Okay,
You only take the permit 3 times until you fail it. So how does that work? If it's 6 months again?
okay, on number 11, determine whether a triangle, okay, with the given side lengths is 45, 45, 90, or 30, 60, 90, or neither. So, number 11 says the sides of the triangle are 1, square root of 3, and 2. What kind of triangle would that be?
30, 60, 90.
That's a 36. That's like my base ratios, right? So that, yeah, that has to be a 30, 60, 90. Here's how they wrote that. Just like that. Number 13 says 7, 7 square root of 3, and 14.
30, 60, 90.
Yeah, that's like this one. 7, 7 square root of 3. If that's 7, 14, that would be the one possible 30, 60, 90 triangle. Okay, if all the odds are 30, 60, 90, guess what the evens are? Probably going to be 45, 45, 90. Well, actually, neither is an option also, but we got to look for that. 15, 12, 12, 12 square root of 3.
Neither.
Yeah, that almost looks like what? 12, 12, 12 squared root of 2, that would have been a 45, 45, 90. If it was 12, 12, 12 squared root of 2. But it says 12 squared root of 3, so it's not quite right. So it's neither. I just noticed the rule is I before E except after C, but that doesn't work here.
I think you realized that last year.
Not on either. I know it doesn't work on the word weird, but that's just because the word weird is weird. There's probably a lot of words.
I think you realized that last year too, like the I before E thing. I think
Every year is a fresh revelation.
Does that mean 16? What else is it?
16. 4 squared root of 2, 4 squared root of 2. So if you had two sides that are 4 squared root of 2, that could be the 45, 45, 90. But how would you find out what the hypotenuse is supposed to be? Yeah, if you multiply this by square root of 2 and it equals 8, then it would be a, well, 4 square root of 2 times square root of 2, square root of 2 times square root of 2 is 2. So really this is 4 times 2, which is 8, so it actually does work. Okay, then we're jumping to number 19 through 24. So let's turn the page. Number 19 says, find the area of each triangle. State the exact area and a decimal approximation to the nearest tenth. You guys know what the 10th place is? First decimal place, so 1 decimal place. So they want the exact answer like with the square root, and then they want the decimal answer rounded to the 10th place. What kind of triangle is it on number 17? Yeah, but it had a special name. Equilateral. Because they put those marks on all the sides, so that means they're like all 8. Do you remember what the angles in the equilateral triangle were? 60, 60, 60, because they all have to add up to 180. So that's important because, okay, how do I find the area of a triangle?
Base times height divided by 2.
Base times height divided by 2. So what am I missing?
The height.
The height. So I need to draw it in there. It's got to be perpendicular to make it height. So what did I just kind of draw here?
2 triangles.
The 90, 60, 30. 30, 60, 90. So I can use my, 30, 60, 90 stuff. I could also use Pythagorean Theorem, by the way. If you forget 30, 60, 90, how long do you think this is going to be right here? 4. Yeah. These two triangles are congruent by like hypotenuse leg. But yeah, that's a 4. I could use Pythagorean Theorem, 4 squared plus the height squared equals a squared. We just did that on number 22 on the last assignment. But I'm going to use, it's faster if I just use my 30, 60, 90. If the short, this is the short leg, you guys see it? If the short leg is 4, what's the 4 squared root of 3? 8 is the hypotenuse, we already have that. But we need this right here, 4 squared root of 3. Okay, so I have the base is 8, the height is 4 squared root of 3, so what's my formula?
8 times 4 square root of 3.
Forgot something. Divided by 2. So 8 times 4 squared root of 3 divided by 2. If you have a good calculator, you can do it automatically, but I don't really. 8 times 4 is 32. Square root of 3 divided by 2. What's 32 divided by 2 is 16. I'll put it up here. 16 square root of 3 yards squared. Okay, but it also said put the decimal approximation.
27.7.
Okay, most of your, well, all your calculators have a button that you can push to turn it into a decimal. depends on which calculator you have, because they're kind of different in different calculators. But yeah, I think is it 27.7. So both of these are the answer. The squiggly equals means about equal to. So our first answer is exact. Our decimal answer is rounded off because it's an infinite decimal.
20's a bit weird.
Huh?
20's a bit weird.
Okay, on 20, you notice the bottom two angles are 60. So what would the top angle have to be? 60. So it's equal. So it's same thing as number 19. It's an equilateral triangle again.
That's the square root of 2 instead of
We'll just
It's, yeah. So when you're going from,
divide by 2.
yeah. So 4 square root of 2 would also go along the bottom of the triangle. You know what I'm saying?
Oh, okay.
So this right here would be half of that because it's,
So would that make...
well, or it's half of this basically. So it's just 2 square root of 2 on the bottom.
And
And then-
square root of 2.
Right. So you times square root of 3 to get to this
So
side.
it's
So what would that make that square root of
2
5?
No?
square root of
Gracie got it. Say again.
2 square root of 6.
2 square root of 6. You can multiply square roots together. Square root of 2 times square root of 3 is square root of 6. So it's 2 square root of 6 for the height. That's not the answer, guys. That's the height of the triangle. If you need more help, you have to ask for it. Because we still got to do 21 and 23. Okay, 21 is basically the same thing as what we just did, where you're supposed to find the area of the triangle. It's another 30, 60, 90 looks like. And they give us 18 is the what? Hypotenuse. So how do I go from hypotenuse to short leg? Divide by 2. So if this is 18, then this guy is 9. How do I go from the short leg to the long leg? Times square root of 3. So it's 9 square root of 3. Well, that's nice. We found all the sides, but the question was, what's the area? So how am I going to find the area? Base times height divided by 2. But what's my base? What's my height? Well, on a right triangle, you can use the legs as the base and height because it goes straight up. So I can use the 9 and the 9 squared, so I just turned it sideways like this. I can use the 9 and the 9 squared root of 3 as my base and height. So it's base times height divided by 2. 9 times 9 is 81. Times square root of 3 divided by 2. Since 81 doesn't divide by 2, you can leave it like that, but move that over here. Because we're supposed to label it as centimeters squared, but we're also supposed to put the decimal on this one. So somebody plug that in a calculator. Huh?
Oh, wait, never mind. I don't have the decimal. Oh, I do have the decimal.
We need the decimal version.
Oh, I have the decimal.
Huh? 70.1? Anybody else get that?
I got
See.
9.79.
Okay, it is 70.1. I just looked in the book.
7.1.
70.1. So the top answer is technically better because it's a exact answer. The bottom answer might be more useful because in real life, if this is like something a carpenter's like cutting out or something, he's going to need the decimal answer, not that one. So this is the exact answer. This one might be more useful. Okay, anyways. 23. I'm going to turn 23. What shape is 23? 4 equal sides. And it's telling us that the angle over here is 60 degrees. I turned my rhombus sideways, you might have noticed, because it's probably easier to think of it like this. And it tells us that the sides are 6, so these are all 6s. Okay, how do I find the area of a rhombus?
Base times height.
Yeah, it's in parallelogram kind of thing, so it's base times height. Now, we did learn a different formula for rhombus on Tuesday. Do you guys remember what it was?
Side 1 times side 2 divided by 2.
No, that was a...
Just kidding.
Okay, you're kind of close though. I think you might have... It's
Diagonal. That's what I meant.
diagonal times diagonal divided by 2, yeah. And that worked for rhombus and what else? Kites, yeah. But a rhombus is just another parallelogram, so you can also use base times height. So what am I missing? What information do I lack?
The height.
The height again. So I got a base. I can use 6 for the base, but I don't know what the height is yet. But look, what a little coincidence. We got a little 30, 60, 90 triangle right here. So this 6 right here goes on this side of the triangle. So what side of the triangle is that? Hypotenuse. So if this is 6 on the hypotenuse, what would the short leg be? 3. If the hypotenuse is 6, the short leg is 3. And if the short leg is 3, what's the long leg? 3 squared of 3. So you divide by 2 to get the short leg, and then multiply by square root of 3 to get the long leg, right, which is the height. So area of a rhombus, we can just use the base times the height. 6 times 3 square root of 3. 6 times 3 is 18. You really don't need a calculator for this. Well, actually the second part, we do need a calculator. What's the
Inches.
inches? What's 18.3 is, or 18 squared root of 3 as a decimal?
7.8.
7. No, it should be bigger than 18. Square root of 3 is bigger than 1, so this is 18 times something bigger than 1. So it should probably be a little over 20.
31.
No, that's not right. It's not squared, it's square root of 3. 31.
31.2.
Bigger than I expected, but this inches squared is not actually squaring anything, it's just part of the label. This is just the number right there, anyway.
How did you get the 31.2?
18 squared of 3 and well, depends on what calculator you have. On that calculator, yeah. Maybe fractions decimal would work. You might have to change the mode. Somebody, you know how to change it to decimal on this one without changing the mode?
Yeah.
What did you hit? See that? Yeah.
Do a second?
No, I don't think so.
Thanks, Mom.
All right.